Hi everyone, my name is Charles. So this video covers one of the problem in Data 605 final exam. So this question is all about completing the Kaggle competition for the housing price. So the target variable is the sales price, and there are a lot of explanatory variable which is given in the training and test data. I loaded the training data sets and test data sets. So as you see here, there are 80 explanatory variable, and one is a target variable which is the sales price. And in the test data also you have 1459 observations, and these are all new data set which is used to test the model. So we have 80 explanatory variable here also in the test data sets. So I did a summary of training data set, and this is the summary data which shows the min, medium, mean, max, everything. So I can see some of the missing values here. I don't see much of a missing value, so I don't need to worry too much about correcting the missing data. So okay, so the next thing is to build the histogram on sales price. I can see the histogram is basically a rightly skewed histogram, and I did some box plots between some of the explanatory variable versus sales price. The first thing is type of dwelling. I can see the family, the single family detached and the townhouse end units are having highest mean sales price. So it looks like there is some relation between these two variables. And I did the same thing, box plot analysis between type of foundation versus sales price. I can see the green one, which is the poured concrete house has the highest mean sales price. Similarly, I did it for neighborhood. I can see the mean sales price is highest for Northridge Heights and Northridge and Stonebrook neighborhood. And this is against the overall quality versus sales price. I can see if when the quality increased, then the sales price is also increased. So it looks like there is a good relation between sales and the overall quality. So then I did the correlation between two variables. One is one independent variable and other is a target variable. So like I did the correlation matrix between taken couple of numerical variables, and then I did a correlation matrix. So looking at the correlation matrix, I can see there is high correlation between sales price and the full bath, garage area, year built, overall quality, living area. So I did a hypothesis test on couple of set. So I can see garage area versus sales price. The correlation is 6.62, and with a confidence interval between I did the hypothesis test on correlation between each pair set variables. First thing is garage area versus sales price, and the correlation is 0.62, and it is 80% confidence that 80% confident that the correlation is between 60 and 0.660 and 0.64. Similarly, I did it for living area. Here is a correlation for the 80% confidence level, and next thing is I inverted the correlation matrix, and you get a precision matrix, and then if I multiply the correlation matrix by the precision matrix, you will get a identity matrix. So if you flip it, you will get again the same identity matrix. So now let's do the LU decomposition for the correlation matrix. So I have taken a function which is basically one of the assignment task to build a LU decomposition function. So I have used it. Then I have decomposition into LU, L and U, and then multiply the L and U, you will get the same correlation data. So the next one is the feature engineering and the selection. So since you have 80 explanatory variable, it's quite difficult to find out which feature is highly correlated. From the correlation matrix, we found few of them, but here we are using a backward elimination process to remove some of the non-significant features from the training data set. So I did a backward elimination. It's quite intensive process. It's a iterative process. So let's go at the bottom. Okay, so in the final stage I got around 22. Okay, so the backward elimination selected around 39 independent variable, which covers both quantitative and qualitative. So there are a lot, again 39. So out of 39 explanatory variable, we still need to reduce some more independent variables, because this is more. Apart from that, if you look at the testing data set, there are some missing values over here. For instance, MS zoning, we have missing values, and there are a couple more independent variable which has missing values. So there are a lot of categorical variable and quantitative variable which has missing values. So in that case, it's really difficult to fix categorical missing value. It is easy to fix quantitative missing values, because if we can fix it, or we can fix it by imputing the mean of that particular independent variable, we can easily fix those missing values for quantitative variable. But for categorical variable, it's really difficult to do the imputing process. So for that reason, I'm planning to drop all the categorical variable and then impute the missing quantitative variable with their mean value. So that's what we did here. So this will extract out all the numerical variable, and some of the numerical variable which having missing value, I'm computing the mean and then imputing it to the missing value. Otherwise, if the value is there, then we'll retain the original value for those observations. So after that, I did a summary. I made sure that none of the quantitative variable has a missing value. Finally, we were able to reduce to 22 independent variable, and with that 22 independent variable, we built a random forest, and this is the method which predict the sales price for the given test data, and the test data will get all will extract out only the 22 independent variable, which is basically all the fields are numerical variable, and then I write it down into the submission.csv. Then I have submitted the result data set in the CSV format and the Kaggle, and the score which I got is 0.15170. Yeah.